everyone to another episode of Indexer Office Hours. Today is the 31st of January, and this is Indexer Office Hours 92. And if anyone is new to Indexer Office Hours, this is the town square for Graph ecosystem participants to come together and discuss the most important and relevant topics for indexers. And by that token, we love participation. This is a conversation. So at certain parts of today's call, we'll have opportunities for you guys to voice your opinion. And you can do that either by text in the text box or by unmuting your mic. And with that, we move into the next section, which is Matthew from PinX, who's going to talk all about Firehose.
Yeah, this is my first time presenting on IOH. So been here for a while, but you haven't heard my voice before. So I've been in the IT industry for, I don't want to count, 20 some odd years. Used to work for one of those big Fortune 50 companies doing software development, and managed to escape that, and now spend all my time doing nice decentralized applications and indexing and all that good stuff. Upgrading Aragon, I guess. Okay, so Pinax. So Pinax is a company that started a few years ago, and was all focused on Web3 and, a lot of stuff related to the graph. And we have our own indexer now. So thanks to the MIPS program that trained us how to run an indexer, we do have a few subgraphs on the indexer. We run our own bare metal servers in leased data centers. So lots of fun managing all of that hardware equipment. We're a self-funded team. And mostly teams in Canada, but we have a few people all over the world. Next slide. So today's agenda, this is really introduction to Firehose. So people may have heard about Firehose, but don't really know much about it. So just want to kind of introduce the topic. Future sessions, depending on your feedback, what you want to hear about, we can go into much more detail about aspects of Firehose and how to configure and stuff. But anyway, today we're going to do high level. What's Firehose, architecture, kind of talk about hardware requirements, and starting to do some planning. So not only do you have, Aragon, Polygon, more chains, more L2, etc. Well, you can start thinking about Firehose. All right, let's go. Next. Okay, so what is Firehose? So Firehose is a blockchain agnostic way of storing and retrieving data. So as we get into when you're familiar with the graph does the same thing. It exposes a common interface to end users to do GraphQL queries. So Firehose is kind of a little bit more low level, but it has the same goal of abstracting away all the details about all the blockchains and providing a consistent interface to use. It allows applications to stream data and understand when there's a reorganization or a fork, as we call it in the chain, and the stream will roll backwards and then roll forwards again. And as an application developer, you don't have to handle that. So that's a very great feature with Firehose. The idea behind Firehose is you extract everything you need from the blockchain and store it in flat files. And then you never have to go back and run the RPC nodes again and pull data out of them. So the flat files allows things like parallel processing in the future with substreams. We're not going to talk about substreams today. Maybe we can do that another time. But once you have flat files, then, if you have 1,000 processors, well, they'd be up the load and have them all processed in parallel. Great activity there. And we're going to talk about Ethereum chains mostly in this presentation, but Firehose works with any of the other chains as well as Ethereum. So if you wanted to replace your existing graph node and use Firehose today with Ethereum, you could do that. Next slide. All right, so we're going to talk about the architecture. So first off, there's a few different pieces that need to work together, and I've got a picture on the next slide. But first off, you need an instrumented blockchain binary or an execution layer client. So for an Ethereum-like chain, it's Go Ethereum. We're not using Aragon here. So that has to be enhanced. So it's not the standard one that you would just download, but you have to get the one from the Streaming Fast website, GitHub, and that's the one you use. It has extra instrumentation that publishes all of the data that we need in order to generate the blocks. Depending on which blockchain you're on, you need a consensus layer client or you don't. And then you need the Firehose binary, which provides a bunch of different functionality, which I'll go into detail. But the Firehose binary is, blockchain stack specific. So there's a Firehose binary for Ethereum chains, there's one for Cosmos chains, there's one for Airweave, et cetera, et cetera. But they all work kind of the same. So once you know how to use Firehose for Ethereum, then if you want to do Firehose for Cosmos later, it's like 99.9% the same. So it'll be really easy to figure out when you get there. Next. Okay, so here's a little architecture slide. So we're going to start on the top right, which is the the consensus layer client. So if you need one, kind of set that up first, and it's going to be connected to just left of it the blockchain special binary. That's your execution layer client with extra pieces added to it to enrich the data. So that's the first two things. Then that execution layer client is connected to the Firehose reader. So there's one Firehose binary, and it provides the functions of the reader, the relayer, the gRPC, merger, like all those other pieces there underneath. All those are functions of one binary. It just depends on the configuration file. So anyway, so the reader is going to read all the blockchain data and put that all in a store somewhere. And then relay the current blocks across a gRPC connection, eventually over to the end user, which can connect onto Firehose gRPC. So if you're working with the latest blockchain data, we call it live blocks, you never really have to hit the disk. All the data is just going through gRPC stream calls, and it streams out to the end user, which might be an end user directly connected to Firehose, or it could be GraphNode or some other thing that you've set up that you want to connect to the Firehose gRPC endpoint. In the Ethereum chains, you also need an archive node to handle ETH calls. So the whole Firehose infrastructure handles everything except ETH call. So we need an archive node or some equivalent thing that provides archive node-like functionality in this architecture. Then at the bottom, there's a couple other pieces that are managing data, and we'll get into that on the next slide. So hopefully this makes sense as an overall picture of how Firehose fits into the infrastructure that you have. Obviously, I've oversimplified it with just putting GraphNode there. I didn't cover all of the graph infrastructure that you would already have. Next slide. All right, so just going into the components in a little bit more detail. So the reader is reading all the blockchain data and making it available to all the other components. So all the other components in Firehose don't talk to your blockchain node. So the reader is the one isolating the Firehose from the rest of the blockchain ecosystem, if you like. It's also the one that the reader component is the one that's very different between blockchains, depending on the what that blockchain looks like. The relayer is the one pushing live blocks around. It can also look at the historical blocks when it starts up, so then it can get the current state and then work on the live blocks. The Firehose gRPC server, so that's the end user facing function. It can serve either live blocks or the historical blocks. So the live blocks will come from the relayer, just on the socket. Here's the new stuff. Here's the new stuff. Here's a fork. We roll back. Here, go forward. It's just a stream of information coming across. Or if you connect to Firehose and you say, I want to start from block 1 or block 0 or whatever the first block is of your chain, great. It will just go to the store, get all those blocks for you, stream them all to you, and then when it gets caught up to live, then it will send you the live blocks. All transparent. You don't have to do anything. All right. The other cool thing about the Firehose gRPC endpoint is that it can handle reconnects. So if bad things happen, you get disconnected from Firehose, you get a cursor. So cursor is a kind of just a opaque string which tells Firehose when you reconnect, you say, I last left off here. Great. Let me resume you exactly where you left off. So you don't have to worry about missing anything. If the last block you have got forked out and it's not on the main chain, Firehose will start from there, reverse backwards to where that fork joins the main chain, and then go forwards again wherever you left off. So it's really, really convenient. You don't have to worry about missing something. Next slide. All right, so the merger is a piece of tech that is taking all the Firehose blocks that are coming along and then merging them into kind of bigger files. So when the reader runs, it creates things called one block files. So a one block file contains, well, one block, right? So every time there's a new block, write a new file. So if there's a block every 12 seconds, then you get a new file every 12 seconds. If there's a reorganization or a fork, well, you might get a few more. In Polygon, the blocks are 2 seconds. Other blockchains, depending. So all those blocks once you have enough of them, then it's a bit annoying to manage all those small files, so they all get merged into one bigger file. In Ethereum-like blockchains, that merged block file, or Firehose block, is 100 blocks exactly, always 100. In other blockchains, they skip over block numbers, 1, 2, 5, 7, 12. So in those cases, you'll have less blocks in your merge block. But anyway, a merge block starts at block ending with 00, 01, 02 up to 99, and that creates a merge block. So once we have a merge block, then we don't need all those little individual one block files, so they can be erased. Except we need to keep the ones that got forked out, because, well, if you have a cursor and you need to resume, then we need to know where you resume from. So we need to keep those kind of forked out ones for a little while, a few hours, a few days, just to be able to resolve those cursors that are coming back. So those are stored in a fork block store. So I didn't do a slide with the layout here, but you can imagine a directory structure with kind of 3 directories here. You have one blocks, merge blocks, and the fork blocks. So the one block files, they go in, they get eaten up by the merge block and then get erased. And the fork blocks are the ones the merger can't merge because they're not the canonical chain. They end up in fork blocks, and then after a few days, then the fork blocks kind of get erased. So the merger manages rearranging all these files. The search ender is another piece that looks at all the blocks and builds a nice search index. So if we're searching through all the Firehose blocks for all of Matthew's transactions, for example, if we have to open up every block and look at it, it's a bit slow. So the search index, gives the Firehose some hints about which blocks to look at. So those are stored in another directory. So we've got one blocks, merge block, forks blocks, and search index. Next slide. All right, so as I mentioned earlier, we need some archive node or similar kind of technology that can provide the Ethereum, the ETH calls. And I've just put an example configuration for your graph node. So you're going to provide 2 endpoints in the graph node. You're going to provide the Firehose endpoint and the archive node. And that's how you set up Firehose from a graph node integration perspective. In a future session, we can go through what is all the configuration files for Firehose, but we don't have time to do that today. So just quick high level. Next slide. Okay, hardware requirements. All right, so hardware requirements. Well, it depends. So what are you going to do with your Firehose? Are you trying to index like the world's biggest blockchain? Which, and you want it in high availability, or, you just want to test something and run it on your laptop. Well, you can do any of those things or anything in between. So Firehose is very flexible. It's designed as a cloud native application. And by cloud native, just meaning it can expand or contract as necessary, and you can deploy it with Kubernetes and use the Kubernetes scaling capabilities. That will all work with Firehose. So just have to think about for Firehose, how big are your blocks? That just impacts your storage. There's blockchains that have frequent blocks, but they're kind of empty, or maybe they have less frequent blocks, but they're kind of more full. How much history? So Firehose can start at the beginning, block 0 or block 1 or whatever the beginning is. Or if you don't want all that history, well, you can just start it from now and ignore all the previous stuff. Obviously, then you couldn't sync any subgraphs that start earlier than now. But Firehose does not require in itself that you index every single block in the chain. So you can erase the old ones if you don't need them. The other thing from a scaling perspective, you have to think about, how many concurrent sessions do you have? So, and the kind of as I alluded to earlier, if it's a session that's live blocks, so if you're just streaming the latest block coming from the chain, that's a lot less infrastructure that you need compared to, okay, let's look through all 20 million blocks that we have and then find the blocks that we need and stream them out over to GraphNode to populate my gRPC. So from a scaling point of view in Firehose, you need to think about, am I going to synchronize 500 subgraphs and they're all live? Okay, easy. 500 subgraphs, but I'm going to start them from scratch. Well, that's much more load, right? So that impacts your scaling. Okay, next. All right, so we talked about storage a bit. So there's the 4 different directories of stuff we can store. So Firehose allows you to store it in kind of wherever you want it. You can store it in S3 bucket. You can store it in Google Cloud Store. You can store it in Azure, or you can store it on your local disk. Use whatever tech you want. You can mount a drive from remotely, NFS, whatever. I would advise maybe not using ext4 because performance problems when you start, loading 200 million blocks in one directory, it might get a little slow. But other than that, any way that you want to store the blocks should work. Just consider the performance of what you're trying to do with the storage mechanism that you have.
Isn't that a consideration for pretty much anything that you can store the blocks on?
Sorry. You need to consider performance, yeah.
No, I mean, like what you said, the 2 million blocks in a single directory, that's a problem pretty much anywhere you would store them.
Well, depends, right? So Firehose typically doesn't do a directory listing, right? Which is the thing that's very expensive or takes a while in a cloud storage or, ZFS or something. Typically, it does look up. The files have a very defined name. Like the very first block is like 0000000, right? So if you need it, you can just grab it. But yeah, directory listings are definitely painful. But the merger needs a directory listing when it starts, but otherwise you don't really need to do directory listing.
Yeah, at some point, sorry, maybe it's going off topic now, but I started wondering why we are not making subdirectories here. For example, like the first million blocks go in one directory, and then the next million blocks, and so on. Therefore, you limit the amount of maximum, and then that's like maximum 10,000 files in a directory.
Yeah, I think it's I think I filed that enhancement request actually, like maybe 3 years ago. But hasn't been done yet. So if enough people ask for it, then maybe we can convince the Streaming Fast team to work on it. Okay, let's move on. Hardware considerations. We store stuff on HDD. It's a massive amount of data to store, and putting all that on NVMe drive would get a little bit expensive. So depending on how much speed you want out of it, HDD might be fine. We're actually using replicated HDD, so it's not just stored once, it's stored across a whole cluster. Anyway, it's on the next slide. Next slide. Okay, so here's Pedro was mentioning in the chat about the sizes. So I just started looking through all the sizes of various different things here and threw it on a chart. It's all in gigabytes, so the numbers look big. The BNB archive node has a little star beside it because actually we don't have that installed. And I think if you run it on ZFS with compression, it's probably about half the size that's listed there. But anyway, start thinking about the amount of storage that you need because it is significant. And, the future of the graph is going to be, huge numbers of chains, right? So this is just a few. You imagine when we get to, 50 blockchains. All right, next. Okay, so let's just talk about our deployment of Firehose a little bit here. So we're using LXC containers. We're talking to the GraphOps team about Kubernetes and Kubernetes Launchpad and how we might migrate to that. But at the moment, we're using LXC containers. We're using Ceph for S3 object storage. So we're not using Amazon S3, we're using Ceph S3. So that way it's on-premise. We're using ZFS for local storage. It's been interesting playing with Polygon Aragon on ZFS. We're doing Consul for service availability between the different Firehose components so they can publish their availability. And we're using Nginx as an HTTP proxy or gRPC proxy in the case of the Firehose. For our server infrastructure, we have some older servers for the HDD storage. We've got the latest Ryzen for blockchain nodes and trying to process Polygon. And most of the other requirements for Firehose, just, a reasonably modern Xeon type or Epic machine would be fine. Try to get fast storage, though. And our Ceph storage is, as I said, mostly on HDD with some NVMe for the file indexes and so on. Next. So let's talk about high availability. So Firehose, you can run it, as I said, kind of one of everything. Run it on your laptop. Well, you need a little bit of a beefy laptop, but you can run all the requirements for Firehose all in one if you want. Not very high availability there, but you probably more want to run at least, for example, 2 readers. So if you're doing an upgrade on one, then it doesn't take it offline and not be able to process blocks for the existing users. And how many graph node connections are you going to have? Maybe you need to run a whole bunch of Firehose gRPC endpoints. Whatever, you can scale these components, just make a copy, connect it into the cluster, and you can create more or less as required. You only ever need to run one search indexer and one merger. So those ones you don't need multiple of. And I just threw a note here at the bottom here. Lots of people have problems syncing their blocks. Just make sure your firewall is open so you're allowing the incoming peer-to-peer connections. Next. All right, so kind of homework time. So planning. As indexers, you should start thinking about how you're going to be deploying Firehose, assuming that you want to deploy Firehose. Look at bare metal containers, Kubernetes, Docker Compose, whatever. What's your storage? How many blockchains? How do you plan to manage all this? Piece of advice that we learned the hard way is make sure you set up Prometheus monitoring from the start. Gives you good hints about making sure all of the Firehose components are working as you expect. So all the Firehose components are Prometheus enabled. The other thing to think about is versioning. So, there's new versions of blockchain nodes, there's new versions of Firehose, how you're going to manage all that stuff and make sure that you can upgrade and not break anything from a test environment and production environment, if you want to think about it that way. And just a note on rare occasions, especially if you're going to index a blockchain that's kind of new to Firehose, you may need to regenerate all the blocks again at some point. I think for Ethereum and Polygon, we're on the third version of the Firehose blocks in the last year. So I'm not expecting that to happen in the future, but think about how you're labeling your S3 buckets or your directories so that you understand, which version of what stuff is running. And if if you're running a reader on the current one serving existing customers, then you're running a reader to replay blocks to catch up to generate the new version, and how you're going to manage that. So a lot of thought process needs to go in the deployment thing here. The other thing is the execution layer, you don't actually need all the old blocks in there. So feel free to prune the old state, prune the old blocks out of that. Starting from a snapshot is fine. Starting from a snapshot just gets those blocks, and going forward, you actually need to let the node replay every block on the peer-to-peer and let it sync in order to generate the Firehose block. You can't just, give me an archive node, download, and then it can inspect that and get all the blocks. No, it doesn't work that way. You actually have to let it replay block by block. But you can clean up the old ones when they're no longer needed. Next. All right, so that's it for the overview. I guess we'll... maybe Pedro has some comments about what we're going to do with Firehose in the MIPS, and then we can take questions.
Yeah, thanks, Matthew. This is amazing. I've been dying to see the Firehose being discussed more broadly with indexers, so that's finally happening. That's great. During MIPS, we're working on it, right? I think that's the only thing we can say right now. But we're trying to get some missions out there for you folks to start playing around with it and have an extra incentive to do so and share feedback with us during while on testnet. Could also be a good alternative to the Polygon things that's been happening, meaning an alternative to serve Polygon. Because Aragon is broke, and we don't really know how that will play out or how much time it will take them. At the same time, we have Streaming Fast folks here with us today as well, but I'm not so sure if we can share much, but there's a separate component they've been working on that could also replace the need for Aragon or any other service to serve archive data like the ETH calls. But that's all up and coming. I think it's still early to start discussing this, but just to share that in the future we should have a way to sync all of this while not requiring the typical JSON RPC APIs and all of these execution client to serve data in such a large scale, which doesn't really scale well, or it's hard to maintain. So Firehose and MIPS, not sure yet. Probably in a couple weeks we'll say something about it. That's all I can say for now. We're still working on it.
Perfect. It's just the fact that it's coming. I just want to, really highly recommend people start thinking about the requirements here, and then ask me questions. So I'll be in the Firehose Indexer channel all the time. So you're perfectly welcome to, as you're thinking through some of the topics that I raised here, ask questions about how you think that should be set up or not. I'm just trying to read through the questions in the chat. Details about networking. Yeah, I skipped networking.
You're good, Matthew. I think it's just the
stream. Yeah, I was looking at Abel's desktop. Yeah, sorry.
Would you like to keep it up?
No, fine.
Okay. Sorry.
Yeah, I just thought I was disconnected. So, sorry. Networking. Yeah, so I skipped over networks. And so all the components do have 10G networking between them. Again, this is going to depend on your volume. We are looking at deploying, 100G networking in our data center in order to handle the storage volume for the upcoming substreams. So not all the nodes are going to have 100, but we need 100 gig backplane in order to parallel process all of the data. So we're looking at that. So yes, 100 gigabit networking. But anyway, our current architecture is all 10, so it works with 10. What else the questions did I miss here? Oh yeah, so can we share the flat files? Yes, the flat files are shareable. So from a consensus or verification point of view, every indexer who produces a flat file should look exactly the same as every other indexer who produces a flat file. So these will be verifiable on the network at some point, hopefully. So yeah, so you can check your flat files against somebody else's. It looks like we will have. We're aiming to provide some of these for download. So the last thing we want to do is have all the indexers try to sync all the chains from scratch. You know, like something like Binance Smart Chain would take many months to synchronize all of those blocks. So that's probably not a productive use of time. So we'll look to share with what we have with the rest of you. Probably starting with
That's actually a good. Oh, sorry. Yeah, Matthew, that's actually a good question. You mentioned months to sync for BSC, or BNB chain, whatever they call it these days. What is that for Polygon then?
I actually don't know. So we synced Polygon I don't know, maybe a year ago, I guess, and I would have to go back and check the notes to see what we did. But yeah, I mean, these things are measured in months, not days or weeks, typically. The volume of data is just too high. Yeah, the other thing that... Sorry, go ahead.
Yeah, I wanted to say that for most things, Polygon is only slightly behind BSC. When it comes to Aragon, when it comes to Firehose, it's just slightly behind BSC as a rule of thumb.
Yeah. What I was going to say, which I didn't put in the slides there, is we actually keep regular backups of the full nodes. So that uses up quite a lot of disk space, actually. So if we ever need to replay the blocks, we don't actually have to start linearly at block 0 and play forward. We can say, hey, we have a backup from block, well, we can start block 0, and we have a backup from block 2 million, and we have a backup from 4 million, and block whatever. So we can actually replay all those in parallel. So we actually keep the old backups from, as we built the chain from the first time, and that if there's a new version of Firehose that requires rebuilding all the blocks, we actually have all those backups so that we can rebuild it quickly. Obviously, backups can be stored on HDD, or you can just store it in cold storage and get them out when you need them.
Yeah, one thing I could probably add, because it's related, is that if we do have these Firehose missions, I've been discussing with Matthew ways of sharing this data too for those that want to participate and just download the data from them faster.
But, this is blockchain and decentralized, so I would encourage people to also generate some blocks and compare, make sure we didn't mess something up.
Yeah, it would be cool if there's some way to hash whatever data we have in well, personally, I'm leaning towards merge blocks, but it seems we don't necessarily agree on that. But sort of that we can hash whatever we synced and therefore can compare with the hashes of somebody else, basically.
Yeah, I think that would be a great idea. Just create a hash every million blocks or so and then publish it. And then we can just, hey, yours the same as mine? Yep, we're good. Would be pretty easy to do that with, say, using substreams. So we could create a substream that's the block index hash substream and then calculate the hashes and publish it. And then everybody can check. Any other questions? All right. So anyway, as I said, start thinking about it. As you come up with your deployment plans, ideas, whatever, let's get into the Firehose Indexer channel and discuss it. Happy to have those conversations. I would love to, just to note, have those conversations in the public channel so other people can learn. So it'd be great if people can share that way. Much more effective than having, 400 private discussions. Yeah, we'll share the presentation. I don't know what the normal way is to share it, but yeah, for sure, we can share the presentation.
Before we wrap this Firehose conversation, sorry, Abel.
No, please.
You were going to say, okay, I was just going to ask something quickly. I see we have Matthew. I thought we had Stefan also here from Streaming Fast, just giving them the opportunity to speak or say something about the Firehose work they've been doing as well, if there's anything that they want to share.
Well, I don't have anything specific, to be honest, so not sure what you were expecting, Pedro, but
just wanted to give you the opportunity to say something, really.
Thanks for using Firehose, everybody.
There you go.
Happy to help anyone that has kind of problems with setting their Firehose instance or stuff. The Firehose documentation is very bad. It's not good. Maybe bad is a little bit hard, but it's not that good. That's it.
PRs are welcome, of course.
Of course.
I think Firehose documentation, especially from an operator perspective, is mostly in the heads of people who have been using it so far. I think the Firehose documentation for devs might be more on point at this point.
Yeah, so let's take this as the first step to improve the operator documentation, if you like. So as I kind of allude to, happy to do more sessions on Firehose, especially when it comes related to operations for indexers. So, just send suggestions, and then we'll schedule future presentations. I think that's it, Abel.
That is indeed. I want to thank everyone for attending, everyone for contributing. This was another episode where I learned a lot. So yeah, I look forward to seeing you all again next week, same time, so that we can talk all things POI Radio and Graphcast. Take care, everyone, and enjoy the rest of your day.